Good evening, judges and professors. I'm the captain of the team, Joshua.
And I'm Cristiano, the mechanic.
And I'm Thomas, the programmer.
And I'm Sebastian, the cameraman.
And we are the Great Area team from Macau Pushing Middle School.
So now we are going to do setup of our robots. So this is the live demo, and this is the environments that we're going to show. So this is our environment, and our live demo will start in here. So the aim of our development is to let our robot understand more about the human world. By achieving it, we focus more on image processing this year. In the following demo, we will show object relationship, follow me, pose detection, and recognition. So last year, we used the original follow me from Turtlebot, but we found out that if there's a third person coming between the robot and the human, it will follow him. So this year, we used YOLO, OpenVINO's person re-identification model and PD control. So this can prevent the robot from following the third person and also prevent the robot from following the edge of the wall. Knowing the relation between objects and humans is a significant technology in robot development. We have used YOLO and a noise reduction function to get the information of objects. Besides detecting objects, we can also find out whether a human is in danger or not. We can divide its stairs as fall, sit, squat, and stand. We used OpenPose and a self-trained model in this feature. Except for getting our robot to notice the real-time world, we aim to build a user-friendly robot. So we have adjusted the angle of the screen, and we have also been designing the whole robot by getting a container and also a manipulator. In this story, we will simulate an elderly man where he goes from his home to the park for a picnic and heads back home afterwards.
Follow me now.
So,
follow me now.
Okay, no worries.
So from now on,
please let me see your map in 3 seconds.
So in the blue bounding box, our robot will get the front initial photos and the back initial photo of our elderly. So for example, there's someone walking across the robot. It will detect another person as red bounding box and our elderly as green bounding box. Actually, how we can achieve this function is we use this bounding box to put it into our OpenVINO's photo model, and we have a descriptor out. So we can compare the initial descriptor and the real-time descriptor. So if the real-time descriptor is similar to the initial descriptor, we will say that it is the same person. So we'll explain it later. And also right now, our elderly have arrived to the park.
Anchor, let's sit here for rest.
Okay, I will stop.
So you can, in the real world, lots of elderlies will forget things because of the increase of age. As a result, we need computer vision to help us detect what the elderlies are bringing. We used VOC dataset in YOLO, which detected 20 objects, including humans, to achieve this function. In the right top image, you can see that we can detect a bottle which is in the green bounding box and also the human in the orange bounding box. So when the object is too far away, we have also added a noise reduction function so it won't be detected. So you can see right now, if there's another human coming inside, it will be a gray bounding box, which means that it is not the main character. So how we can do it is because we calculate the two humans and find out which is more near to the centroid.
Anchor, let's go back home now.
Okay, let's go now.
So actually how our robot can follow is it uses the centroid in the bounding box, it uses the X value of the bounding box to do the turning, and also the Z value of the depth camera to do the front and backward. And we have also added our own PD control to let...
Hey Cristiano, you forgot to bring your stuff.
What did I forget?
You forgot to take your map and bottle with you on the table.
Oh, silly me. Wait for me here.
Okay.
So actually right now, our robot can get the relation between the humans and also the objects. But for now, because I'm doing a classification of which objects belongs to which humans is a bit difficult. So we haven't do this function yet. So, but in a real life situation, for example, someone wants to steal the robot.
Follow me now.
Okay, no worries.
So you can see on the middle screen, the bounding box in red color. So it won't follow the person, the robot. But because we have a 2 seconds, 2 seconds validation. So as you can see here, it won't follow the human. So now, So now our elderly will go back and find the robot. And as you can see here,
I anchor. Let's go.
elderly. So in life for this, real-time situation, for example, in here someone bumped into the elderly. So we need to ensure the safety of the elderly by using our pulse detection. So from now on, you can focus on the right down.
I feel dizzy now.
You can focus on the right down photo.
Do you need me to call the cops?
Okay, team, you may want to.
Hello, Cristiano. Somebody is down.
So you can see
Please
that
help.
there's a skeleton.
Somebody is down. Please help. Somebody is down. Please help. Somebody is down. Please help.
So you can see the skeleton and also the word fall. So actually we have trained our own pose detection model. First of all, we use 3,000 data set images to train our model in danger warning.
Okay, your time is up. So please, jury, you can start ask question.
Okay. Yeah, we are ready for the question.
Jury member, you can ask question. If no question, you can continue add any details you want.
So okay, so actually basically the post detection we have trained our own model. For example, in here we used VGG16 and also the CNN model to train our model. So in conclusion, actually we hope to push the development of home robotics by combining image processing features with the robot. We believe that with our development and technology, we can keep contributing to the RoboCup community and hopefully let more students know about this competition. Yeah.
Jury members, do you have any question?
Hi everyone. Do you hear me?
Yes, Jonathan can hear you.
Yes.
Please proceed.
During the following task, if an obstacle stop in the middle, in between the robot and the person, what happens?
So
do you use a map or do you use only the vision to follow the person?
So actually we didn't use any map, we just used the follow me because we can track whether the human whether the person is the target person or not. So our robot will stop for a while, but after the people have passed, it will follow the right person again.
So in this task, we used OpenVINO's person via identification model, which as its name, it can track the target person that you first included and then avoid all non-target persons.
Okay. Thank you.
Any more question?
Yeah, I have a question. Can you hear me?
Please be fast because the time is up.
Okay, just quick question. How much computing power do you need for training and for the running neural network? I mean, do you need really much power, or is it easy? It's easy to run your neural network, for example, on a Raspberry Pi?
Okay. Actually, running those deep learning models is very waste of computer processing powers.
Okay, I
So-
have to stop the presentation because the time is up. Thank you.
Okay. Thank you. Thank you
Thank
very
you
much.
very much.